Today we are going to look at the two-sum problem from LeetCode. Therefore, the problem definition is like this. Therefore, there is a given array of integers, and we are supposed to return the indices of two numbers such that they add up to a very specific target. Therefore, if you see at the example, right, this is the given array and this is the target that has to be achieved. Therefore, we have to find two numbers from this array such that the sum of those two numbers is equal to the target. And if you see here, right, the 2 and 7 make up to 9, and 2 is located at index 0, 7 is located at index 1, and we are supposed to return the indexes, not the numbers themselves, right, which form the sum. And the other assumptions also that is given is you may assume that each input would have exactly one solution, and you should not use the same number twice. That's the other thing. Okay. Therefore, let's copy the function definition, that is the dummy definition that's given here. Therefore, another thing we need to also notice is that there is a note over here that tells that the returned array must be mallocked and assume caller calls for the free. So basically, whatever the return we are doing, right, return of these two indices, the memory for these two indices has to be mallocked, and we are supposed to return it too. Therefore, let's copy this dummy definition to our favorite editor, and let me also include #include stdio.h if I decide to do some debugging. Okay. Therefore, the first thing, the simplest solution for this is what I can think of is I'll take this array, I'll iterate through the array, and each time I'll fix a number, and I'll use one more iterator so that I can go through the array the second time to find the second number. Therefore, I'll use two iterators to find the two indexes. This is not the optimal solution. We'll see what's the optimal solution next, but this is where we'll start with. Therefore, let me use I and j as two indexes to the array, and we are supposed to also malloc right, the memory which is required where we have to store these two indices. Okay, let me do that also, and therefore let me use a malloc here, right. Therefore, return array equal to malloc. Therefore, it is 2 into size of integer, right, because I have 2 there. And let me typecast also the return type of the malloc to int star. If I remember, malloc should be part of stdlib. Let me include that too. .h. Okay. Therefore, we have malloc. Let me quickly also check if return array is for some reason null, right, then let me just set the return size, right, as 0. Basically, it means that I have not allocated anything, there is nothing, and I'll return null, mentioning that there is nothing. Okay, this is one of the error conditions that I'm handling it this way. Okay, now going to the solution, right. Therefore, I will iterate through I and j. Therefore, I'll start with the index 0 of the array. I'll go through the end of the array, which is given by num size, right. Therefore, this is one iteration through the array, right. The other iteration, I'll use j. Therefore, the initial value of j which I will set is I plus 1. Okay, the reason it's I plus 1 is I need not start from 0, because I would always choose the first number, right. Therefore, the first number and the combination of the rest of the number, that's what I am supposed to do. Therefore, j will always start at the next position of the I, because I don't want to start with I, because in that case what would happen is I would be reusing the same number twice, which I'm not supposed to do, right? It was already mentioned in the problem definition that you are not supposed to use the same number twice. Therefore I'll start with I plus plus. J also will go till the end, right? And J plus plus. Okay. Therefore when I hit the condition where sum of two numbers, right, which are indexed by I and j, if they are equal to target, then I break out of the loop, right, or I can return directly from this function. Therefore the condition is the nums, right, of I plus nums of j, right, should be equal to target. Then I know that I have to return here. Therefore before returning I need to set the return size, right? Now return size is equal to 2, right? And I have to also fill in the return array. Return array of I is equal to 0 is equal to I, and return array of 1 is equal to j, and I can return the return array here, right? And say for example I don't find my target in the whole of the loop, right, and the loop exits without hitting this condition, right, then I know that I have failed to find the solution. Then in that case I'll make return size as 0, and I will also free my return array, right, because nobody is going to access this, right, and I will return null in this case. Okay. Therefore let's quickly also write a small driver function for this so that we can test it here, right? Therefore int main, and let me have an array, right? Let me have the content of array exactly like this, 2 7, right? Then the return size, let me have it as also declared, and let me have the target, right? Target as a variable equal to 9, right? And I'm supposed to also get the the pointer, right? Therefore let me declare the pointer here. Let me initialize it to null, even though later it will get initialized. P equal to sum, and the first parameter I have to pass is that of the array, then the size, the number of elements, right? Therefore this I'll find out using size of a divided by size of a of 0. Therefore this will give me the total number of elements. Then next I am supposed to pass in the target, and next I am supposed to pass the address of the return size, right? Now if, right, rs is equal to 0, right, then it means that it was unsuccessful. Therefore I can just print a message telling that target was not, or target not found, right? That's having in simple present tense is good. And else, right, it means that it's successful in finding the target and I want to print the target. Printf target found at indices %d and %d, right? And I can access here p of 0 and p of 1, right? And once this is done I have to free p, because that was the agreement, right? The function to sum will allocate it, but the free has to happen from the driver function, right? Therefore I can free it, and that's it. I just say return 0 here and I'm done. Therefore let's compile this program now. Therefore there are some warnings. Oh wow, okay, sorry, in a hurry I forgot to make it as an array, my mistake. Yeah, I think that was the only error. Therefore the output is 0 and 1, and if you see back, right, our target was 9 and it's able to find 2 plus 7, which is 0 and 1 indices. Therefore it's working. Therefore let's try for some other input. If, say, for example, whatever I pass is a null pointer, right, then what would happen, right? I don't pass anything, say, for example, right? Okay, we are seeing a segmentation fault. This is not good. Therefore let's do some more error checking when this function is called. Okay, therefore if the return array is null, we are returning return size as 0. The other condition that we could add is if nums equal to null, right, then also we'll have the same thing. Or we'll also have one more called as if num size, right, is, say, less than 2, right, then also we'll have the same condition. Because if num size is less than 2, then we can't find any 2 sum, right? We need at least 2 numbers to find the sum. Therefore this is one more condition. Most probably we will not have a test case where num size is 1, but you never know. It's always a good practice to do some error handling if it's not going to consume a lot of processing. Okay, we'll compile again, we'll run it again. Okay, target not found, which is what we expected, right? And let's I think let's revert back so that we have a good test case running. Okay, now we have our solution, which is a brute force solution. Let's copy this solution and paste it in. Okay, let's copy the solution. In the solution part of the LeetCode, let's paste it. Let's run the code to see if for one test case is it running fine before we submit. Actually, yeah, it's working. Let's submit now. Hopefully we get a positive result. Okay, it passes. But if you see, right, the runtime complexity, the runtime statistics out of it is that it's faster than 71.42. Therefore this solution is not efficient enough, and we had guessed it initially also because we are using O of n square, right? We are using 2 loops there to do that. Therefore we were expecting that it won't be fast enough. Therefore let's try to see the solution where we can speed it up further, right? The second solution for this. Therefore let me go back here and to our solution. Let me comment this solution and let me put it in a hash defined, right? And this was our brute force, right, solution. Let me just put a hash define and hash else hash endf. Let me copy the prototype again so that we can rewrite it again using a different method now, right? Okay, the other solution which I have in mind is to use a hash table, right? Therefore this is using hash, right? We can try to solve this. Therefore how using hash, right? If you go back to the problem, therefore this was our array, right? What do we do is each time we will have one iteration of the array. Each time we go through an element, right, say 2. Therefore we try to find the number what is required to reach the target. Therefore target is already known and we have the number 2. Therefore we try to find in the hash table whether the number 7 is there. Of course, when you're starting initially there would be nothing in hash table, therefore it would return that 7 is not present, which is okay with us. And next time when 7 is the number, the iterator is pointing to 7, right, then we see 9 minus 7, which is 2, and we try to see if 2 is present in the hash table. Therefore 2 would be present because it was the first one, right? Therefore once we don't find, right, we have to insert it into the hash table. That, yeah, first we have to find the remaining number. If it is not there, then we insert the present number, telling that this number was already visited. Therefore when 7 is the iterator is pointing to 7, right, he will try to find if 2 is already present in the hash table, which would be, and then we will return it back. Therefore this is a solution. Therefore to do this we need a small hash implementation in C, and we need to find we need two functions for hash find and hash insert. Therefore let's work on them. Therefore let me use the hash table implementation. Let me implement using it using an array. Therefore let me have a static int. Let me call it as the array for this hash table as hash array. Let me have the size defined right there, so that I could let me initialize using a function. Therefore yeah, hash define hash size. Let me have it as 10 because initially I want to debug. Therefore I don't want to have a bigger size, but eventually when I am submitting I will increase the number so that it works more efficiently, right? Therefore let me have an initialization function. Therefore initialization function, let it not return anything, let it also not take anything, right? I'll assume that it's going to initialize only one hash, which is hash array, and what I will do is here I'll memset it the hash array right to 0, and I'll pass the size of hash array. Okay, this should do it. I think memset is part of string.h, therefore I have to include even that. Let me come back to my hash init. Therefore hash init is done. The other functions which I need is insert. Therefore as part of insert let me write the prototype. Therefore what I am inserting, I'm inserting a number right in the hash table, right? And the way I'll do it is if, right, if it is, if the number, right, number n, I will modulo it with the hash size, and if this is equal to say 0, then I know that there is no number already there, right? Then I can insert it. Then I'll let me insert the number, right? The number into that position. Okay, let me see. Else what I will do is I will return -1, telling that okay, the insertion failed, right? And in this case let me return 0, telling that the insertion was successful. Therefore that's another condition. I want to know whether the insertion was successful or failure. The other thing I need to also find out was finding, right? Therefore the same thing, I need to find the integer in that, right? The same thing, I can use the same logic right here. If I find it there, if it is not equal to 0 now, because then what I do is I just return whatever was there, right? Whatever the number was there. And in the other case I can just return -1. Therefore if the find returns back with -1, it means that it couldn't find, and if it returns any positive number, the indexes obviously will be a positive number. In that case yeah, therefore this is the hash find as of now. Let's see if it works or not, right? Therefore in toSum, right, I need one iterator as discussed before. Let me have it as I. Therefore I would still require the malloc and whatever we had before, right? All these conditions would still be required. Therefore let me copy it from my previous solution here directly. Okay, therefore after this let me have the for loop. I could have copied also the for loop, but it's okay. Let me type it out again. I less than num size and I plus plus, right? The first thing I do in the loop, right, as discussed, first we try to find, right, if. Therefore what I have to find in the hash, right? Hash find, and I have to find the target minus the present number. I have to find whether the remaining number is present, right? Nums of I, right? Therefore, if I don't find, right, then I would get -1. In that case, what I would do is I would insert it, hash, if I don't find, insert the nums of I. Therefore, if I do find, then I would hit the else condition. In that case, I know now that from the return array, right, one of the index is I, okay, but I don't know the index of the other number, right, which the hash found out. Therefore, we have to slightly modify now. Therefore, I should not insert the number itself. I should insert the index where the number is there. Therefore, say for example, if 2, 7, 11, 15, it is there, right? I should pass the number 0, number 2 here, but I have to insert the index of it there. Therefore, that's another change now. Okay. Therefore, I here is where then the index, or let me call it as IDX, where it will get inserted, right? The value that has to get inserted. Therefore, let me do like this, right? And when I return, I know that's the index. Therefore, there is a slight change now, right? In the insert, I have to pass nums of I as well as I now, and when I find, I'll get the index back. Therefore, let me declare one more variable, the index from the hash table, right, which I get back, and let me initialize it to IDX before comparing it to -1, right? Then I know IDX is the other one. Therefore, in this case, I is from the array, IDX comes from the hash table, and then the return size is 2, and I can return of array here. And if I don't find, same thing, right? I have to free the return array in this case, and I have to again return size as 0, and I have to return null in that case. Okay. Yeah, I think this should work. Yeah, let's try to compile and see whether it will work or not. Okay. If define, that is a syntax error. I didn't observe it at all before. It should be hash if defined, not define. Okay, no compilation errors. Let's see whether it works. Target not found. Okay, let's go back. Therefore, do we have the correct driver function here? 2, 7, yeah, we should have found it. Okay, we need to debug now. Therefore, let me write a small function to actually print the hash array. Let's see. Void, let me call it as a print hash, and it doesn't take any parameter. It assumes that I'm going to print the hash which is there in hash array, and let me also take a message here so that I know from where I am printing it, right? Therefore let me do printf of message first. I can directly pass like this. Then for I is equal to 0, I less than the hash size, and I plus plus, right? And let me printf of %d. Let me have some convention where I print the index first and I print the value next, and say I have a comma after that so that it looks better. And I need to print first I and then I and then the hash array of I. Okay, and at the end let me print f \n, right, so that it comes in the next line. Okay, let me call print hash say after this print hash, and the message here is say ins, because this is during the insert, after the insert, right? And find also, let me I'll have it during the positive test case. Okay, let me have it as a find or f. Oh wow, sorry, yeah, fin. Okay, this is fine, therefore it's equally spaced. Okay, let me compile again and see where our problem is. Printf format string literal. Okay, let me see what is the issue there. Oh, I think it has to be a constant int, right? Otherwise it won't work. Okay, I can make it as a constant. Okay, then let me have this workaround. It's a warning actually, it should not be a problem, but still I don't want to take a risk there, right? Why to have warning? Okay, oh, this is interesting. Therefore the find is never called. Is this okay? Find is never found, that is okay, but it's okay. Let me, in the case of find, always call right here and see what happens, because yeah, find insert. Therefore I see some insertions here, right? That's happening, but why didn't 0 get inserted? Oh, okay, I get it. Therefore 0 couldn't get inserted because this is I think another problem. If I'm using if the hash array has 0, then I don't insert, but if the index 0 has to get inserted, then I have a problem, right? Therefore the default value of hash array, we assumed it to be 0, right? I think that's not going to work. Therefore let's make it as -1. Therefore having -1 is okay, you even using memset, because -1 is all ff, right? Therefore you interpret it as a character or an integer, it's still -1, that's still okay with us. Therefore instead of 0, let's use -1 as the hash array being empty. Okay, therefore the same thing will come here and is not equal to -1 now, right? Then we know that. Okay, let's try now. Let's compile it again and see what happens now. Yeah, now the target has been found because it got inserted here, right? Therefore target has been found, but I don't see everything becoming zeros. That is one more thing. Oh, the insert was never called. Okay, then this is the thing I missed. Hash init should be called here. Therefore why is this, why am I getting a code dump after I did the hash in it? There's something ma'am said. Oh sorry, not hash in it. Oh wow, I didn't observe this at all. This is because of this crazy autocomplete. Yeah. It doesn't look aligned. Let me just change the print. Right. Yeah, now it looks aligned. Basically what happens is once the first find goes, there is nothing in this. Next the insert happens, right? Therefore in the insert the 0th index should have got inserted. Yeah, therefore if you see here for 2 it got inserted as a 0, right? The value 2 is there and the index at which it is there is 0. This is exactly what we want. And in the next find we find exactly 0 is present, and we basically it tries to find 2 and it's found at 0th index and it is written. Therefore this is working as expected. Therefore let me increase the hash size to 5000, around 5000, a bigger number, right, before I submit it. Okay, let's submit now this particular solution to the LeetCode and see what happens. Okay, okay, let me remove the old solution. Even though it worked, it is less efficient. Let me run the code again. Yeah, I think we have to remove the printfs. Therefore let me quickly do that before we submit again, because that would heavily reduce our efficiency, right? Therefore let me put it in a hash if 0, because I don't want this as of now. And let me just comment out the place where the printfs are called, right? Okay, let me run it again. Now I should not see anything in the output. Yesterday out. Yeah, this is good. Okay, let me now submit it and see what happens. It's taking time. Okay, we have got a runtime error, and the error is that the index -4 out of bound. Therefore basically I think this is our hash array and there is out of bound access that's happening on our hash array. And what's the input? The input is 04302 and the target is 0. Okay, I get it now. Therefore when the target when the number what we have is bigger than the target, right, then we will face this problem. Okay, yeah, this makes sense. Therefore the one other also point we can think of is the numbers could be negative also, right? Therefore the other, that is other consideration we should have. Therefore let's do one thing, let's also take care of negative numbers as well as this case. Both of that will get solved. Therefore how do I do that? Is I could offset the hash table, right? I could divide it into half and offset it. That's one thing I could do. Therefore let me just modify the hash insert and thus, right? Therefore any number that comes, right? Therefore let me add hash size by 2 to it. Yeah, hash size by 2. then I will do a modulo operator, right? All hash operations, right, will have this. Yeah, this does make sense. Therefore, basically any number comes, I am offsetting it by half of the hash. Therefore, if the hash size is 5000, it would cater for 2500 of positive numbers and 2500 of negative numbers in that way. Okay, and the same thing will also happen to the find, right? Same thing. Okay, therefore let's see if this solves our problem. Maybe we want to try it out before we submit it, right? Therefore let us 04, let me copy out 0430. Yeah, that is simple. Yeah, let me go and change my driver code, and let's try to emulate it. Basically, yeah, this some of the test case we can imagine before, but some we can't. Therefore that's part of learning. Index 3 and 0. Yeah, it works then. Okay, cool. Therefore let's submit this and see what happens. Maybe since I have divided it, let me double it, right, before I submit it, because my initial idea was to support till 5000. I really don't know till what number I should be. Therefore let me see if this works. Okay, let me run the code before submitting it, just to be sure. Okay, now submit it again. Okay, therefore the output I have got. Okay, I think this is a very huge index, and I see numbers which are more than 10,000. Therefore I think there is a collision in hash table, that's why we are not able to find this. Therefore I think I definitely need to increase the size of the hash table for sure. Therefore let me directly do that in the leetcode only directly, because I know that it's not a big change, right? Therefore let me make it as a bigger. Space is not a constraint right now, and therefore let us now submit it again. Let's see what happens now. This is now 1 lakh. Yeah, see, therefore this is accepted and if you see, it's much faster than our previous solution. Yeah, thank you.